this is your timer unit. Okay, so basically in short range or in low range micro controllers or MCUs, we do not have these facilities of capture and compare. Okay, we just have a free running counter register. Okay, and that will update its value upon the clock. Okay, so according to clock it will update its value. Okay, the counter circuit. Okay, so it will keep on updating its uh, a register. Okay, by incrementing one each time when one clock cycle completes. Okay, now there is a bidirectional movement of the data between this timer unit and CPU unit. Okay, so this data you can actually write the data into the free register. Okay, so that you can tell the timer that so that from where it can start run. Okay, so if you have timer
like countdown.
countdown, right? So if you have like this uh, from 16-bit 16-bit timer register. Okay, so you have to count like okay, so you will go like this. Okay, every time. So from 00 you will go to this. From 00 you will go to F, right? Okay, so this is the initial condition you have given or you have written to the register. Okay, your free running counter register. Okay, if initially you will write something else, then it will go to F. Okay, suppose if you write something else, suppose I write like this F 09. Okay, so I'm writing this, suppose 09 FF09. Okay, so it will go from FF09. So initially from the CPU will write FF09 to the register, 16-bit register, and then it will be updated and it will reach to the maximum value, that is FFF. Okay, so initial value we can write down initial value in the register so that I can get the exact timing what my application requires. Okay, understand? Because in if I take FF09 to FFFF, so this counting or this updation will require will consume that much time which is required for my application. Okay, so this will be my calculation what I have to write initially in the free counter timing register. Okay, it is according to my need. Okay,
Got it.
yeah, so so this
And
is
then
about
the free running counter, let's assume you go FF09 and it counts all the way to FFF. When it hits FFF, does it come back to FF09 or does it come back to 000 and then recounts all the way back up to FFFF?
It depends. It depends on the microcontroller actually. See, in this it depends on the microcontroller. It will return back to FFF09. In almost I mean in general I can see in most of the microcontrollers it will return back to 0000, not to FFF09. Okay.
Okay.
It will get back to 0000. Okay. So again I have to repeat the process. Again after overflow I have to write again FF09 into the register. Yes. Okay. And in some microcontrollers it is a facility as a counter, na. So what happened? There is a pin. Okay. There is a pin in the microcontroller, and that is dedicatedly for the counter purpose. Okay. So if I give some type of signal on this pin, then then the counter will update its value. Okay, according to that event. Suppose and this event can also be configured actually. I mean, suppose I have configured the event for rising edge or falling edge. You understand, na?
Yes.
Rising edge, or it may be low level or it may be a high level. Okay. Yes. So suppose I have made it for rising edge. Okay. So whenever on that pin comes your data like 0, initially it was 0. When I give 1 to it, so it will it will have a rising edge, and then your counter will update its value. So it has been seen that one event has been occurred, okay, and it has been counted. Okay. And after that, again 0 will come, and then 1 will come, then again rising edge will come, and then counter will update it again. So I have got 2 events. So my counter value is 2 now. So I am counting the events, okay, not the clock.
So independent of time, you're counting events.
And see, it is independent of time. Actually, it can come anytime. So that is the application of counter, okay. And if my register value is updating according to the clock, according to the specified non-clock, then it will be used as a timer, okay.
Got it. Okay, totally understand.
Yes. After that, what do we have is, we have compare in most of the good range microcontrollers, or we can say high-end microcontrollers like ARM or AVR, PIC. Okay, we have compare mode and capture mode for the timers. Okay, and what are these actually? So have you heard what is capture mode or what is compare mode?
No, I'm not familiar with them.
Okay, so in this what happened actually, let's start with the capture mode. Okay, so capture mode is used, basically I'm telling you the application. Capture mode is used to find out the delay or the time taken by event to appear. Okay, I mean, what is the time taken by that event to appear or to happen? Okay. Or we can say after what time an event is occurred. So that time can be recorded in capture register. Okay, and how we can work on it? Suppose I have started my timer. Okay, my timer has been started. Okay. And in capture register, what do we have is, we have a dedicated pin in the microcontroller for the capture event. Okay, you can see here there is a signal, event capture signal. So that signal is directly connected to the pin. Okay, the microcontroller pin. So whenever the event will come on that pin, the value of the timer register at that moment of time, okay, is recorded in the capture register. So whenever the event will come, it will capture the event and it will record, it will take the snap of the value which is at that instant of time is available in the timer register or in the free running counter register of timer. It will be saved to that pin capture register. So I can analyze through this value that after how much time the event has been occurred.
Got it.
Understand? So it will
the same thing, it can be configured. It can be configured on a rising edge or falling edge.
It can be configured. Yes, absolutely.
Okay, I got it. So this one, for example, if I wanted to measure frequency of high events on a pulse,
exactly. You can measure the frequency also of the signals. Exactly. Okay.
Got it. Yes. Thanks.
Yes. So these are the two facilities that are very much related to your timer. Okay, timer circuitry, right? Okay. And there is a very important thing actually there related to timer is your PWM generation. You understand what is your PWM generation?
Pulse width modulation.
Actually this is very much useful in your robotics systems.
Even driving an LED or a motor or something like that.
Even driving an LED motor. Yes, you can actually control the intensities of the LEDs, or you can control the speed of the motor, okay, by using the PWM. And you can also control the position of the position of the servo motors using the PWM generation. Yes. Okay. So that is also related to timer, and there are certain registers related to it. I have to configure them. Okay. So I'll show you when we'll work on the processor actually, or a microcontroller. Okay. So that's all about the timer unit.